Wetlands. While many people, and maybe even you, see a swamp, a scary place that should just be drained and used for something more useful, like a Walmart parking lot or the state penitentiary. The goal of this video is to show you what these birds or this alligator already know. The importance of wetlands, not just today, but how we can integrate them into our future and adapt to a rapidly changing world. All in an easy-to-digest, numbered list. But before we get into how wetlands can make humanity more resilient despite our best efforts to make the future uncertain, I want to quickly define the different types of wetlands. There are 4 basic types: marshes, swamps, bogs, and fens. Marshes are identified by the primary vegetation being herbaceous and not woody, so less trees, more grass, and can be either freshwater or saltwater. Swamps are dominated by woody plants, especially trees, such as the ancient cypress swamps of southeastern North America, or mangrove swamps, which can be found along tropical coastlines worldwide. Bogs and fens are both peat accumulating, with oxygen-poor waters that prevent the decomposition of organic material. The difference between the two is that fens are fed by mineral springs that make them more alkaline than acidic bogs. Anyway, let's go over why wetlands are so important for climate change adaptation and mitigation. Number 1. Wetlands are carbon sinks. Wetlands often have areas where decomposition is slow and organic material builds up and stays more or less intact. Preventing the carbon in the material from being released is carbon dioxide, especially wetlands with lots of peat. Places like this, where more carbon goes into than comes out, are called carbon sinks. Wetlands are basically sponges. This is going to keep coming up during this video, pulling in excess carbon and sequestering it. However, wetlands are also the largest natural contributor of methane, a greenhouse gas far more potent than carbon dioxide. However, peatlands, which compose many existing wetlands, sequester more carbon than all the forests on the planet. Many coastal wetlands, like mangroves and salt marshes, are also really great at sequestering carbon and not releasing excessive methane. The carbon stored here is known as blue carbon, and similarly, more carbon is held here than in many other ecosystems. Number 2. Home for wildlife in a changing world. Of course, wetlands are also really important biodiversity reservoirs as the climate dramatically changes, a place of dependable water and food. On the edge of a swamp in Florida, a bird of prey lazily circles over the water's surface, looking through the water's reflection, searching for prey below the surface. With a quick shift of the wings and tail, the bird enters a dive, splashing into the water and carrying off the prize, a large apple snail. This is a snail kite, a bird, as the name suggests, which has a taste for escargot. Snails might be slow, but they are in some ways quite challenging prey. They are well armored, able to retreat into their thick shell for safety, and hide behind their operculum shield, which acts as a lid. The kite flies to a perch with the snail and uses that distinctive curved beak to dig into the shell and pull the soft flesh out, though trying to balance a round shape on a thin branch takes some good foot placement. Snail kites are uncommon in Florida, but have been increasing in number after the introduction of an apple snail larger than the native Florida species, which have done very well in the shallow waters of Florida, and a rare case of an introduced species helping a native species thrive. A loud shriek pierces the air. Another bird in these wetlands is on the search for apple snails, the limpkin. These are unusual waders related to rails and cranes which stalk the margins of water, looking for tasty snails in the shallows. Got one. Like the kite, the limpkin has to deal with the snail's defenses, so takes dinner back to shore. Pressing the shell into the mud, the bird then uses their long chopstick-like beak to expertly get past the operculum and remove the snail from the shell in just seconds. Both of these species are far more widely distributed than just Florida, and are common in neotropical wetlands all the way down to Argentina. Their range and unique escargot-based diet a testament to the richness and value of these ecosystems. Beyond specialists like these birds, many other species utilize wetlands: migratory birds, shoals of fish, reptiles, and amphibians. So protecting wetlands is an important way to retain biodiversity across the planet. Number 3. Protecting keystone species that are important for surrounding ecosystems. Elkhorn Slough is one of the largest tidal marshes on the coast of California. A critical foraging habitat for many birds on the Pacific coast, this wetland is also home to the greatest concentration of sea otters in California, and so has been important in the conservation of the species after they were nearly wiped out by fur traders. Sea otters have a major impact on ecosystems they inhabit, particularly the highly productive kelp forests of the Pacific coast, like those out in the ocean just beyond the slough in the rich marine ecosystems of Monterey Bay. Home to a diverse community of marine life, kelp forests are home to a whole cast of characters, from the familiar to the otherworldly. Salps are so strange looking. One resident, though, the sea urchin, feeds on the holdfasts of kelp, destroying this forest of macroalgae and leaving urchin barrens unsuitable for kelp forest inhabitants. Sea otters, though, love a tasty sea urchin, making the sea otter a classic example of a keystone species. Keystone species are species with a disproportionate impact on the ecosystems they inhabit. Beyond just preserving the rich biodiversity of these ecosystems, which feeds the tourism and fishing industries of the California coast, healthy kelp forest is really great at sequestering carbon, taking some 200 million tons of carbon into the deep each year. So sea otters, cute and also important allies in the fight against climate change.
The National Oceanic and Atmospheric Administration, or NOAA, recently allocated $2.2 million towards restoring part of the Elkhorn Slough in an effort to protect this biodiverse ecosystem from sea level rise. To learn more about the project, I spoke with Dave Felice and Monique Fountain from the Elkhorn Slough National Estuarine Research Reserve. One of the reasons it's important to restore an ecosystem like the Elkhorn Slough is because it takes up a lot of carbon from the atmosphere. Sea level rise makes this complicated because it can chip away at the ecosystem, releasing that stored carbon. And yet, elevating the marsh reduces its growth rate, so it will capture carbon slower in the short term. So restoration projects like that at the Elkhorn Slough have to weigh the short-term and long-term carbon sequestration benefits. Check out my channel at the Bekisphere Climate Corner to learn more about what goes into a marsh restoration project.
Number 4. Flood control, storm protection, and shoreline stabilization. With a climate becoming more and more chaotic, there are going to be more frequent and more devastating storms. These forces of destruction will cause flooding and devastation along the coasts. In the tropics, a healthy mangrove forest like these at the very southern tip of Florida create a green shield against storms, protecting the city of Miami from storms coming over the wetlands. Mangrove forests have saved villages from cyclones and tsunamis, protecting 15 million people from loss of their homes and potentially their lives. The roots of mangroves also hold sediment back from eroding into the sea, protecting threatened coral reefs, giving one less thing for coral to be stressed by with a changing climate, and keeping the coastline intact as sea level rises and increased storm activity threatens to wash it away. Finally, a fifth reason wetlands are important in a changing world: water purification and groundwater replenishment. As I said earlier, wetlands are sponges, not only for CO2, but also all kinds of things in water, like sediment and pollution. The plants of wetlands absorb excess nutrients, whether from agriculture or sewage, and take it out of the water so it doesn't lead to a harmful algae bloom that can threaten animals such as manatees. The slower water allows sediments to settle out and produce clearer water downstream from the wetlands. Some of that cleaner water even percolates below the wetland into the groundwater. Groundwater is critical for drinking and agriculture, especially as rainfall regimens become less reliable with a changing climate. Wetlands are really good at recharging groundwater, and their presence ensures the opportunity for groundwater to be replenished. The critical role wetlands have in a time of crisis was illustrated by the Everglades in the 1930s, when after diverting much of the water away from the wetland, a drought then struck the region and the Everglades began drying out. Without the wetlands replenishing the groundwater, seawater made it into the wells that supported Miami's drinking water. This hopefully illustrates why draining the swamp is a really terrible idea, unless you like not having fresh water to drink. While this is no way an exhaustive list of the importance of wetlands in adapting to and mitigating the effects of a changing and more chaotic climate, I hope this video helps show you that wetlands are not just swamps to be drained, but places we need. Wherever you live, you are probably near some sort of wetland, from New York City to desert and marshes. I encourage you to get involved in helping with wetland restoration in your area by volunteering and taking a proactive role in your community's adaptation to climate change. However, wetlands also can use our help to adapt to climate change, especially coastal wetlands as the sea level rises. To learn more though, you need to head over to the Bekisphere Climate Corner to learn about specific climate adaptation projects happening at Elkhorn Slough and hang out with Becky, scientists, and sea otters.